Hi. So for today, I'm going to introduce the paper called Where Do the AMS02 Antihelium Events Come From? So first of all, let me just briefly introduce what is AMS2 and its mission. So it is called Alpha Magnetic Spectrometer, actually second generation now. It is a particle physics experimental module that can on the International Space Station that can help scientists to discover the antiparticles in the cosmic rays. Not so. The discovery of the antiparticles can help us to better understand how the early universe is formed or developed, and better understand the dark matter. So for this article, for the contents of this article, the AMS02 has detected many positrons and antiprotons for many years. So such antiparticles are believed to be mainly due to the secondary productions. So this means that they are mainly produced by the nuclei in the particle showers in the primary cosmic rays hitting the interstellar medium. However, the recent observations described in this particle have deviated from the standard predictions model. So this paper are discussing the different possibilities for the origins of the antihelium detected by the AMS02. And this paper is divided into two parts. So first, the authors are discussing we evaluate the secondary components from spalations within the coalescence scheme. And then they are trying to discuss the possibility of the anti-domains in our galaxy being responsible for the MS02 events. So first of all, the author are giving some basic knowledge for the source terms for the anti-nuclei in the coalescence scenario. This is really helpful for the later discussions in the paper. So especially the term BA here. So BA is the coalescence factors, and A means the number of the anti-nucleons produced in the collisions to merge into larger anti-nuclears. So the next chapters of the early discussions in this paper are talking about some deviations of their findings of the flux for antihelium-3 and antihelium-4 of the MS02 sensitivity. So here is a graph. The red line here is the sensitivity of the flux of the antihelium-4, and the blue lines here represents the flux of the antihelium-3. And there's a gray area here that means the sensitivity of the MS02, and the width of those blue and red lines means the uncertainties of the flux. So we can see that the blue line here means the antihelium-3. It is kind of 1 to 2 orders of magnitude below the sensitivity of AMS02. And the red line here, it is more like 5 orders of magnitude below the AMS02 sensitivity. So these data are obtained from the other devices in the Alice experiment. They are kind of disagreeing with the lowest sensitivities from the AMS02. And then in the next subsections, the authors are discussing some suspects about the why the antihelium-3 and antihelium-4 are having such a low flux. And they give a conclusion that it seems to them that it is really unlikely a boosted productions by the spolations can help to produce such a large anti-helium-3 flux, as well as the anti-helium-4. And then here comes to the next big sections of this particle. So they are discussing the anti-helium-3 and anti-helium-4 as a hint for the discovering the anti-world. So they have discussed about these two anti-helium particles in two environments. So one is for the anti-clouds and the other one is for the anti-stars in a dense environment. And first, the first subsections, they have talked about some exotic Big Bang nucleosynthesis as an explanation of the anti-helium isotopic ratio. And their so the ideal ratio, or sorry, not ideal, but the standard model of the ratios between the helium-4 and the helium-3 should be 10 to the power of 4 to 1. But according to the devices or the project called the Pamela, the ratio just reaches 5 to 1. And it is also lower than AMS02. But for no matter what devices, the results from the devices are disagreeing from the standard models. I'm sorry, the predictions. And so then they are discussing some conditions for the survival time of the antimatter in the Milky Way and the early universe. So here, this is the formula for the time that is given by the author. Annihilation time. So this annihilation time is related to the Z, which is a redshift factor. So this confirms that, so in these sections, they have confirmed that antimatter must have formed in a region where their surroundings have really low densities of protons, so that the annihilations only occur at the borders of the antimatter dominated domains. Then they are discussing some constraints from the CMB. Actually, for over a decade, observations of the CMB have been used to constrain some scenarios that can lead to the exotic energy injections, in particular dark matter annihilations. And then they're also talking about using the gamma ray to observe, the gamma ray observations to place limits. So in these sections, they mainly talk about three types of searches, providing some strong constraints on the exotic physics, including dark matter annihilations or decays. So so the first type of the search is the distinctive spectral features, as would be the case for a gamma ray line. And the second type is that morphological features localized on the sky, either from extended sources or from point sources on the sky. And third is the continuous spectrum of gamma rays extending over a large area over the sky. So as for instance, from the extragalactic gamma ray background. Then they are discussing for using some cosmic ray antimatter observations to look for anti-regions. So I am not really familiar with these sections, but I think that in these sections, they find that the anti-clouds can leave some significant traces in the anti-proton ratios, and so that they think the cosmic rays can provide a really strong probe, strong hints of the anti-cloud scenarios. And then they are talking about some properties of anti-stars from the AMS-02 measurement and constraints on the anti-stars. And they find that it is possible that anti-star whose main source of the emission is annihilations at its surface lights in a caused by environment that is roughly 1 parsec away from the sun. So that but so actually this means that it can happen in our Milky Way galaxy, but not so easily. Then here comes to the conclusions of the paper. So they have talk about the density, the size, and the number of the antimatter domains. They think that these properties of the antimatter could be constrained by the observations done by the MS02, and then they also talk about some annihilation rates of the antimatter in our galaxies would require the anti-domains to be really poor of the normal matters, say like positrons, the electrons, and alternatively, these anti-helium events could originate from anti-stars whose main material is anti-helium-4 converted into anti-helium-3 via the spirations in the dense environment surrounding the anti-stars. So all the points in this particle talk about can be used to build a scenario for the formations in the early universe. So the discovery of the single anti-helium-4 nucleus represents an important probe of conditions prevailing in the really early universe and should be investigated further in the future work. And thank you. This is my presentation today.